All right, let's see. A droplet of mist falls through air with a terminal velocity of 0.00156 meters per second. What is its radius? Ignore the buoyant force of the air. Okay, so what we're going to say is that the Stokes force in this case is the the force of gravity, basically, right? Now, if we wanted to take into the buoyant force of air into account, we'd go density of the water minus the density of the air, right? And then we go times the volume of the object times g, right? This is always sort of the net force, right? Sometimes the buoyant force is bigger if it's if the object is less dense than the fluid, right? And sometimes in this case the mass is big. In fact, they're suggesting that we just do this, right? Ignore the 1.29 because it's small compared to the 1,000, right? And then the drag force is 6 pi viscosity r times the velocity, and then we've got, we'll just go the density of water times 4/3 pi r to the third, that's our volume, right, times g. Now, they want us to solve for the radius. My preference by far is let's not put the numbers in here and solve it that way, especially since there's a radius on both sides. Let's do maths first, okay? So I'm going to cancel out an r. That makes that squared. Cancel out a pi, right? I can even cancel out a 2, right? So this is 3 and that is a 2, right? And now we've got 3 viscosity V equals rho times 2/3 r squared g. All right, let's just double check that. Spend some quality time with it. Yeah, I think we got it. Okay. The next thing I'm going to do is I want to solve for r, right? So I'm going to multiply by 3/2. That gets rid of this. Divide by rho. Divide by g. All right. And now we have what r is, right? So now we've got the square root of 3 times 3 is 9, so 9/2 viscosity times v, right, over rho times g. That's going to be our radius. So that equals the square root of 9. What's our viscosity? Okay, so this is mist falling through air. So we'll use the viscosity of air. Whatever fluid you're falling through, that's the viscosity that matters. So 1.81 times 10 to the minus 5th, right? And then our velocity is 0.00156. And then in the denominator, we have 2 times the density, right? And in this case, we're talking about the density of the droplet, right? Because this side had the water in it. So this is the density of water, right? Times 9.81. All right, time to do this with the calculator. So I'm going to go second square root. I'm going to go alpha f1 because I want a fraction. 9 times 1.81 e minus 5 times 0.00156. In the denominator, I've got 2 times 1,000 times 9.81. And my radius ends up being 3.5989 times 10 to the minus 6th meters, which is 3.60 micrometers. Or microns, by the way. A micrometer is a micron. All right.